Let's take a look at functions that have radicals in them, or radical functions. So remember, a function has an input and an output. So a square root function has an input of x in this case, and the output comes from the square root of x. So f of x equals the square root of x. So if that's our function, then let's evaluate a few functions. F of 1 just means we have the square root of 1, and the square root of 1 is 1. So we know f of 1 is 1. When you put in 1, you get 1. F of 2 is the square root of 2. Well, the square root of 2 is approximately 1.414. Okay. Often we'll just leave it as a square root of 2 if we want an exact answer. Square root of 2. If we want to approximate, we can plug in our calculator. We'll get about 1.414. Okay. The square root of 3, we can find the square root of 3. And if we plug that into our calculator, we get about 1.732. What about negative 9? If we put negative 9 in for x, we get the square root of negative 9. And is that possible? Well, nope. Your calculator will say error or does not exist if you plug that in your calculator. And so that does not exist. D and E. All right. So we can't take the square root of negative numbers, but we can take the square root of any positive number, and we can take the square root of 0. So we have kind of some important properties here. If we have an even index, squared or the fourth power, or fourth index, or a sixth index, then the domain is all real numbers from 0 to infinity, all non-negative, we say, real numbers. So 0 is okay. We can take the square root of 0, right? So f of 0 is the square root of 0, which is 0. But we can't take the square root of a negative number. So if we have an odd index, then you can plug anything in there you want. There's no limit to the domain, all right? So let's think about this here. So if we want to find the domain of square root of x minus 12, so there's a different function. That means this stuff underneath here, x minus 12, has to be greater than or equal to 0. It can't be less than 0. So here we have an inequality. So the way we solve inequalities is like equations, the same way. Subtract 12 from both sides, and we get x is greater than or equal to 12, negative 12, that is. So in interval notation, we'll write that as from negative 12, let me come over here, from negative 12 to infinity. Those are all the numbers negative 12 or larger. Well, what about the range? Well, the best way to get the range is to get a graph here. So going to desmos.com, graphing calculator here, or using your calculator, a graphing calculator, we can have y equals the square root of x minus 12. And let's look at that graph. Well, let's see, where is that graph? We might have to zoom out here, and there it is. Okay, so there's what the graph looks like. And so we notice that the x values start at 12 and go to the right. Remember, domain means what x values we have. So we look at, if we were to take this, get a better line. If we were to take this little blue line here, and we can look for all the values, all right, we notice that there's no points on this blue line right here, and there are points over here. So the first time that we hit, the first x value that the blue line hits is 12, and then there's always points, and that's going to go on forever. It will continue on forever off to the right. Okay. For the range here, we want to look at this green line here. And if I can move the green line, there we go. Okay, so we can say, all right, where where does the graph touch this green line? Well, are there any points that have a y value of -4? The green line is down at -4 right now. Nope, there's no points down there. Are there any points that have a y value of -3? Nope. A y value of 2? Nope. Y value of 1? Nope. -1, that is, sorry. What about a y value of 0? Yes, there is a point right there, because when you plug in 12 here, you get 0. So there is a point that has a y value of 0. All right, and so now, doesn't want to grab this. There we go. All right, we have y values all the way up, 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 and this will, again, this will continue to go on forever up in this direction. So this graph will continue to go up, up, up. So the range here is all numbers from 0 to infinity, all y values from 0 to infinity. And we could say y is greater than or equal to 0, okay? Because we have points that have y values of 0 and on up. All right, so that's a little reminder how to use the graph there. All right, so what about the domain of this fourth root? Well, again, since it's an even number, we want 9x minus 27 to be greater than or equal to 0. So if we add 27 to both sides and then divide by 9, we get x is greater than or equal to 3. So x is greater than or equal to 3, we write that as hard bracket from 3 to infinity. Anything from 3 on up. Well, what about the range here? Now remember, the domain, all the domain matters is we got to make sure that the stuff under the radical is greater than or equal to 0. So for the range, we got to go graph this thing here. So we have y equals negative. We need a fourth root. So fourth root we can get if we go under functions, and let's see. Got to scroll down to now. Decimals will look differently on different calculators. If you're on a phone, yeah, I think it has like some different. The menus are all there. They just got to hit some different tabs. Okay, so we have a fourth root. We got to get that fourth root, not a square root. 9x minus 27. All right, where is that graph? Well, there it is. So zooming out, or hitting, you can hit that home key there. That'll get it close there. All right. So there's our graph. Okay, we can see that the domain, the smallest x value is +3, and that's what we said. X is greater than or equal to +3. What about the y values? Well, the y values, notice they're all below the y-axis there. All right, so if we do the test here with this horizontal line, the first point it touches is at 0, and then there's points down here. All right, so there's no points up here at this level, so the range is below 0. It's all the y values below 0. So y is less than or equal to 0. And so the way we write that is 0 is the high number, negative infinity goes down forever, down to negative infinity. 0 is included, so we're going to put a hard bracket there. Okay? All right. What if we change that a little bit there, and we have the range of positive 9x squared, or positive square root of 9x minus 27. Let's tweak that. So looking for the range here. And there's our graph. The square root of 9x minus 27 plus 5. Okay, and so we can see that the x values start at 3 for the same reason as our last graph did, because of 9x minus 27, but the y values start at 5, and you can guess probably that that's because of that 5, and that's right. Okay, so the y values start at 5 and they go up. So 5 is the smallest y value, and that graph goes up vertically forever. All right, so anyways, there's the domain and range of our radical functions. And now let's investigate next. We'll investigate a little bit about how to get those graphs.